So last class we tried to solve more PYQ questions. Today also we are going to start the PYQ questions and we try to solve it with the help of our chemistry knowledge. So let's start the class. So question number 19 is on your screen. Structure of a mixed oxide is a cubic closed pack. The cubic unit cell of a mixed oxide is composed of oxide ions. 1/4 of the tetrahedral voids are occupied by divalent metal A and the octahedral voids are occupied by the monovalent metal B. The formula of the oxide is. So now we are moving to the solution part. So this question is basically come from your solid state of your class 12 NCERT. So if you see here, they are giving a cubic closed packing, and this cubic closed packing is cubic unit cell is your oxide ions, okay, that is CCP, and it is occupied by your oxide ion. So what is the total number of atoms, or you can say total lattice count for this? It will be 4. Now if you see 1/4 of your tetrahedral voids, so how many tetrahedral voids are there? That is a 8 tetrahedral voids are there. So 1/4 tetrahedral voids, this one occupied by A. So how many tetrahedral voids are there? That is 8. So A, it will be 2. So A equal to 2. Now B is occupied by octahedral voids. See, octahedral voids occupied by B. Now always remember, if your tetrahedral voids, octahedral voids, if it is will be n, then your tetrahedral voids, it will be twice of n. Now how many tetrahedral voids are there? 8. So then how many octahedral voids will be there? It will be 4, and if it will be 4, then your B is equal to 4. So what you are obtaining here? A 2, B 4, O 4. Now if I am solving this one, A B 2 O 2, and AB2O2 is the correct answer, that is option number 1 is the correct option of your question number 19. So now we are moving to the next question, that is question number 20. So question number 20 is on your screen. The orbital angular momentum of p electron is given as. So this question is come from a structure of atom of your class 11 NCERT. So now we are moving to the solution part. Now if you see, the formula which we are going to use to find out angular momentum is L into L plus 1 into h by 2 pi, okay, and for p the L value is 1, okay, for p it will be 1. So now just substitute the value, that is 1 plus 1 into h by 2 pi, 1 plus 1 2 root 2 into h by 2 pi. Now root 2 we can write like this, root 2 into h by this 2 we can write like this, root 2 pi, okay. So now root 2 and root 2 will be cancel it out. So we have to left it out is h by root 2 pi. Now just find it out where it will be given. So if you see among the option, this option number 2, it should be root 2, okay. There is a mistake in the options, so it should be root 2. So h root 2 pi. So option number 2 is the correct answer of your question number 20. So now we are moving to the next question, that is question number 21. So question number 21 is on your screen. 4 diatomic species are listed below. Identify the correct order in which the bond order is increasing in them. So now we are moving to the solution part. Now see, this question is come from your chemical bonding chapter of your class 11 NCERT. So for this you can use this one, okay, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2p z pi 2px equal to pi 2py, pi star 2px equal to pi star 2p y, sigma star 2p z, when your total electron count, if it will be greater than 14, we can follow this order. Now, if our total electron count, it will be less than or equal to 14. So, we just reverse this part, okay. This part means sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, then pi 2px equal to pi 2py, sigma 2pz, pi star 2px equal to pi star 2py, then sigma star 2pz. Now, for that you just calculate the total electron count of these compounds, whatever they are mentioning. So, if you using these formulas, you can easily find out the bond order, but it will consume your time, okay. So, rather than by using these formulas, you just use your common sense. Now, helium 2 plus, definitely no doubt this bond order is obviously lower than the other, okay, that is definitely, because hydrogen and helium. So, it is the second most type, okay. After hydrogen it will be the smallest one. So, obviously if it is the smallest one, the bond order will be less for this. Now, if you see your options, here it will be given in a highest bond order, which is not possible. For option 2 also it is given in a highest bond order, which is not possible. Now, left it out is this first option and your fourth option. Fourth option also helium will given is greater than your C2 2 minus, which is not possible. Only one option is left it out, where helium 2 plus is having the lowest bond order, that is your option number 1, and this is the correct answer of your question number 21. So, question number 22 is on your screen. Which of the following compounds can be used as a antifreeze in automobile radiators? So, this question is come from a solution chapter of your class 12 NCERT. So, now we are moving to the solution part, and the solution is very easy for this types of question, because it is a direct question from your NCERT, which is used for antifreeze. Now, among the four, your glycol, it is used as an antifreeze in automobile radiators. So, option number 3 is the correct answer of your question number 22. So, now we are moving to the next question, that is question number 23. So, question number 23 is on your screen. For real gas van der Waals equation is written as P plus A n square by V square into V minus n B equal to nRT, where A and B are van der Waals constant. Two set of gases are, they are giving one set, that is oxygen, carbon dioxide, hydrogen and helium. Second, they are given as methane, oxygen and hydrogen. The gases given in set 1 in increasing order of B and gases given in set 2 in decreasing order of A are arranged below. So, select the correct order from the following. So, now we are moving to the solution part, and this question is come from your states of matter of your class 11 NCERT. So, if you see, they told you that set 1 means this one, they are giving the increasing order of B, and B indicate the effective size, okay, effective size, and this one is given in A, and A is nothing but this will give you the intermolecular force of attraction. So, it give you the information of effective size, and A will give you the intermolecular force of attraction. Now, in set 1 they are giving an increasing order of B. Now, if you see among this, the highest order is goes to CO2. The order is look like this: helium, then your hydrogen, helium, then your O2, then it will be go to CO2. This is for B. Now, for A, they are giving an intermolecular force of attraction, and A should be in decreasing order. Okay. So, if it will be decreasing order, so the highest one is your CH4, because in CH4 the intermolecular force of attraction will be more, then it will be go to O2, then it will be H2. So, this is for A. So, now let us see what are the options they are given. So, now if you see your options, the first one, that is the order of B and this is the order of A. See the CO2 having the highest effective mass. So, this is the order of increasing order based on B and this is the decreasing order based on A. So, your option number 4 is the correct answer of this question. So, now we are moving to the next question, that is question number 24. So, question number 24 is on your screen. A certain gas takes 3 times as long to effuse out as helium, its molecular mass will be. So, this question is come from your states of matter of your class 11 NCERT. So, now we are moving to the solution part. So, if you see the solution for this, your R1 by R2 is equal to root over M2 by M1. So, R1 is for gas, I am considering this is for gas and this is for helium. Similarly, this is for your helium and this is for M1 is for gas. Now, for rate I can write like this is V gas by T gas divided by V helium divided by T helium, and this one also I can write like this, molecular mass of helium divided by molecular mass of gas. Now, the certain gas take 3 times as long to effuse out as helium. Now, if you see the volume will be the same, so you have to left it out T of helium divided by T of gas. Okay. These two I am going to consider as same. Okay. So, if you see the volume will be the same, that is V gas is equal to VE, V helium. Okay. So, this will be same. So, you have to left it out the time of helium and time of gas is equal to root over. What is the mass of helium? It will be 4 and we have to find out the mass of gas. So, if you see in this your T, here it is written as a certain gas takes 3 times, means T gas I can write like this, 3 times of T helium, right. I can write like this, 3 times as long effuse out as helium. So, here T gas is equal to 3 into T times of helium. Now, T gas by T helium it will be give as 3. Now, if I am taking this T helium by T gas, so it will be 1 by 3, means this terminology it should be 1 by 3. Now, for root 4 it will be coming as 2 and root over M gas. Now, root over M gas is equal to 6. Now, M gas is equal to 6 square and it will be as 36. So, 36 it will be the answer of this question. Now, if you see among the option number 3, that is 36U is the correct answer of your question number 24. So, question number 25 is on your screen. Consider the following reaction. The reaction is given on your screen and they asked about the product A is. So, now we are moving to the solution part. So, this question is very easy and this question basically come from your aldehyde chapter of your class 12 NCERT, okay, aldehyde carboxylic acid, from those chapter it will be come. Now, if you see this reactant when react with this reagent, okay, and this reagent basically used for Rosen-Mud reduction reaction, and we all know in Rosen-Mud reduction reaction the product is your aldehyde. Now, if you see how the structure of A structure is look like this. Okay, it is the product, this is the product. Now if you see here in option number 1, 2 and 3, 4, if you see your option number 2 where aldehyde group is attached, so option number 2 is the correct answer of your question number 25, and this reaction is known as Rosen-Marde reduction reaction. So now we are moving to the next question, that is question number 26. So question number 26 is on your screen. Which of the following reagents will be able to distinguish between 1-butane and 2-butane? So now we are moving to the solution part. So let's see how it look like 1-butane and 2-butane. So your 1-butane will be C, 4 carbon should be there, C, C, C and C. Now 1-butane, it will be look like this. So this is the structure of 1-butane. Okay, see 1, 2, 3, 4. So 1-butane, 1, 2, 3 and 4, 1, 2, 3, 4. Now for 2-butane, CH3, C, C, CH3. So this is nothing but this is your 2-butane. Now if you see in 1-butane we have this acidic hydrogen. So if I am using any strong base, so this proton will be easily abstracted by our base. But if you see in the 2-butane we do not have any acidic hydrogen. So if you see in your option like option number 2 NaNH2, which is a strong base, if I am using this one we can easily abstract this proton, whereas in case of 2-butane it does not have any acidic hydrogen, so you cannot abstract any proton. So NaNH2 we can use to distinguish between 1-butane and your 2-butane. So option number 2 is the correct answer of your question number 26. So now we are moving to the next question, that is question number 27. So question number 27 is on your screen. So which of the following compounds will give a yellow precipitate with iodine and alkali? So now we are moving to the solution part. So it is a very easy question. So if you see, first you have to find it out what is the key point here. So they said that they given yellow precipitate with iodine. So it is nothing but this is an iodoform reaction. Okay, iodoform reaction, and iodoform is reaction is characteristic reaction given by two, all that is one is alcohol, another one is a carbonyl compounds, that is this group, one is this group and another one is these groups. So only these two groups are shown by your iodoform reactions and they give you a yellow precipitate compound. Okay. Now if you see among these four options, hydroxypropane, it having this OH group, another one is acetophenone, it is also look like this CH3, C double bond O, CH3. So only these two, option number 1 and option number 2 will give you the yellow precipitate with iodine and alkali. So option number 1, so if you see the solution here, here two options you are getting 1 and 2. And 1 and 2 is the correct answer of your question number 27. So question number 28 is on your screen. Chloramphenicol is N. So this is the question come from your chemistry in everyday life of your class 12 NCERT. So now we are moving to the solution part. So the solution of this question is very easy. So chloramphenicol basically it is act as an antibiotic. And it is antibiotic, which types of antibiotic is a broad spectrum antibiotic. Now if you see in the options, your option number 1, that is antibiotic broad spectrum, is the correct answer of your question number 28. and the direct question come from your chemistry in everyday life. So now we are moving to the next question, that is question number 29. So question number 29 is on your screen. Given the reaction between two gases represented by A2 and B2 to give the compound AB, they give you the reaction, also they give you the equilibrium concentration, that is for A2 is 3.0 into 10 to the power minus 3 molar, for B2 it will be 4.2 into 10 to the power minus 3 molar, for AB it will be 2.8 into 10 to the power minus 3 molar. And they ask you if the reaction take place in a sealed vessel at 427 degrees Celsius, then the value of Kc will be. So this question is come from your equilibrium chapter of your class 11 NCERT. So now we are moving to the solution part. Now if you see, they give you the reaction, okay, this is the reaction, this not be a equal sign, it will be this arrowhead. So for Kc for this reaction is equal to Kc concentration of AB to the power square divided by concentration of A2 by concentration of B2. Now concentration of AB it is given as 2.8 into 10 to the power minus 3, that is 2.8 into 10 to the power minus 3 whole square. Concentration of A is given as 3.0 into 10 to the power minus 3, and concentration of B2 is given as 4.2 into 10 to the power minus 3. Now if you are going to solve this part, it will be end up with like this 10 to the power minus 3 6, this 3 and this 3, so 10 to the power minus 3, 10 to the power minus 3, and this part will be cancel it out. So you are end up with 2.8 into whole square will be there, so 2.8 divided by 3 into 4.2. So if you see here, if you are solving this part, that is 2.8 into 2.8 divided by 3 into 4.2, your answer will approximately come as 0.62. Okay. Just try it in your home, just do the simple multiplication and division here, and you will get your answer as nearly 0.62. So now if you see among your options, option number 4, that is 0.62 is the correct answer of your question number 29. So now we are moving to the next question, that is question number 30. So question number 30 is on your screen. Low spin complex of D6 cation in an octahedral field will have the following energy. So this question is come from your coordination chemistry of your class 12 NCERT. So now we are moving to the solution part. Now if you see here, they already mentioned it is a low spin complex. It means the pairing take place, okay, and it's an octahedral complex. If you see D6 octahedral field, so it will be split like this, T2G by your Eg, and how many electrons are there? These 6. So so if you see here 1 2 3 4 1 2 3 4 and 5, this is d orbitals, and it will be d6, means 1 2 3 4 5 and 6. Now what will happen? They are saying just low spin complex, so the pairing definitely take place here. So what will happen? You are getting as 1 2 3, rather than jumping it will be paired up 4 5 and 6. Now CFSE, crystal field stabilization energy formula is minus 0.4, this value from here to here, that is T2G, it will be 0.4 minus 0.4 delta naught, where from this to from Eg to this part it will be plus 0.6 delta naught. Now what is the formula for CFSE? Minus 0.4 x, x is nothing but number of electrons present on the orbitals, that is in T2G orbital, plus 0.6 y, y is nothing but the presence of electrons in Eg orbitals, delta naught plus your pairing energy. Okay, pairing energy. Now, if you see here, first one is 0.4 x, how many electrons will present here? 6 electrons, so it should be 6. For 0.6 y, see here no electrons will be there, so this term definitely come as 0, plus Zp, Z is nothing but number of electrons in the paired form. So, how many pairs will be there? 1, 2 and 3. So, 3p. Now, if I am solving this part, that is 4 by 10 into 6, that is it will be end up with minus 12 by 5 plus 3p, okay, delta note 3p. So, minus 12 by 5 delta note plus 3p is the correct answer. Now, if you see among the options, option number 3, that is minus 12 by 5 delta note 3p is the correct answer of your question number 30.